The question says, approximate the integral of e to power negative x squared dx. First of all, to calculate this integral, the regular methods that we're using in the class doesn't work. So we have to use power series expansion. Recall that if you have function f of x equals to e to the x, the Maclaurin series tell us f of x can be written as the summation of the nth derivative at 0, x to the n, divided by n factorial, and start from 0 to infinity. E to power 0, which is f of 0, is equal to 1. F prime at 0 is equal to e to power 0, which is 1 again. The second derivative of f at 0 is e to 0, which is 1. So you can conclude that the nth derivative at 0 is always 1. So e to the x can be written as the summation of 1 divided by n factorial x to power n, and start from 0 to infinity, or this is basically 1 plus x divided by 1 factorial, x squared over 2 factorial, plus the rest of the terms. Now for the function e to power negative x squared. For the function f of x e to power negative x squared, you're basically, wherever you see x, you're going to switch that with negative x squared. Very good. Let us begin. E to power negative x squared is equal to, so you have the summation of 1 divided by n factorial, but your x is now become negative x squared to power n, and start from 0, goes to infinity. So wherever you see x, you're going to use negative x squared. Perfect. So this guy can be written as the summation of 1 divided by n factorial. You have negative 1 times x squared to power 2, sorry, to power n, and start from 0 to infinity. So e to power negative x squared can be written as the summation of 1 over n factorial, negative 1 to power n times x to power 2n, and start from 0 to infinity. Very good, excellent. Now, to find the integral, we basically take the integral of both sides. The integral of e to power negative x squared is equal to the integral of this polynomial. Negative x squared dx is the integral of the summation of 1 over n factorial, negative 1 to power n, x to power 2n, dx. Guys, please pay attention. You're taking the integral with respect to x, not with respect to n. It means that if you write this guy in expanded form, you're basically finding the following integral. This is equal to the integral of, here if you plug in 0 and start from 0 to infinity, you have 1 over 0 factorial, which is 1, negative 1 to power 0, which is 1. So you have 1 plus 1 divided by 1 factorial, negative 1 to power 1, x to power 2, plus 1 divided by 2 factorial, negative 1 to power 2, x to power 4, right? So you continue this process, dot, 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 dx, which is basically the integral of each one of these terms 1 by 1. 1 minus x squared plus 1 divided by 2 factorial x to the 4th plus the rest of the terms dx, or can be written as the integral of 1 is x minus x cubed divided by 3 plus x to the 5th divided by 2 factorial times 5 plus the rest of the terms, right? So what's happening here? You're just changing the exponent for our x because we have dx. There is no dn. So this guy can be written as the summation of 1 divided by n factorial, negative 1 to power n, x to power 2n plus 1 divided by 2n plus 1 and start from 0 to infinity. So that's how you approximate this integral using power series. So let us rewrite this guy down. Negative 1 to power n, x to 2n plus 1 divided by n factorial times 2n plus 1.